In this video, we are continuing section 5.1 on exponential functions, and we will talk about how to graph exponential functions. Exponential functions are functions where the variable is in the exponent, like with 2 to the x. So I want to get right into an example. Let's sketch the graph of this function, state the domain, range, intercepts, and asymptote equation. All right, so I want to do this by plotting some points. Let's plot some points to get a feel for what this graph is going to look like. And I'll plot some simple integer x values like 2, 1, 0. Let's do some negative ones like -1 and -2. All right, if I plug 2 into this for the x, I'll get 2 squared, and that's 4. If I do the same thing and I plug 1 in, I'll get 2. Plug 0 in, 2 to the 0 is 1. 2 to the -1 is 1/2. And 2 to the -2 is 1/4. All right, so let's plot these points. When x is 2, y is 4. When x is 1, y is 2. When x is 0, y is 1. When x is -1, y is 1/2. And when x is -2, the y value is even smaller. It's at 1/4. It's at 1/4. Okay, so let's connect these because a shape seems to be emerging here. So kind of going this way for bigger and bigger x values, the graph gets larger and larger and larger, steeper and steeper and steeper. But then going to the other side of the y-axis, it gets flatter and flatter and flatter, and it kind of snuggles up next to this x-axis. Okay, so that point, this point at 0, 1, has it's something I'm going to call the balance point. And the balance point kind of conceptually is the point where the graph changes from increasing very slowly to increasing very quickly, and it gets very steep very fast. Okay. So the balance point of an exponential function is not always on the y-axis like this, because especially if it gets shifted to the right or shifted to the left or something, it might move it away from the y-axis. And we'll see some examples of that later. Okay, so what's the domain? X can be anything, -infinity to +infinity. The range, my y values, well, the y values get very, very close to 0, but they never equal 0, so parentheses at 0. And then onwards to infinity. All right, and looking at this, my y-intercept is at 0, 1. 0, 1. X-intercept, well, there is none. There is no x-intercept for this graph. But there is a horizontal asymptote, and it's on the x-axis. So the equation of that is y equals 0 as my horizontal asymptote. All right, let's take a look at another example. So the next one, I want to graph 2 functions on the same axes. So y equals 2 to the x, and y equals 1/2 to the x power. Okay, so for 1/2 to the x power, let me make a table of values. So x, what x is, and then what the y value is. And for the y value, I'll just write 1/2 to the x power, just so I don't confuse them with the y values I was writing here. Okay, all right, so I'll plug in the same x values, 2, 1, 0, -1, and -2. All right, so if I plug 2 into it, I'll get 1/2 squared, which is 4. Sorry, not 4. What am I doing? 1/4? If I plug 1 in, I get 1/2. Something to the 0 power is 1. If I do it to the -1 power, well, 1/2 to the -1 power, when I do something to the -1 power, it reciprocals it, and I'll just get 2. All right, that is 2. And if I do it to the -2 power, 1/2 to the -2, well, it reciprocals the number, and then I change the exponent to a positive one. So it's 2 squared, which is 4. Okay, so I'm going to start to plot these 2 graphs. So y equals 2 to the x, well, that one we had already. Let me just redraw those points. 2, 4. When x is 1, y is 2. 0, 1. -1, 1/2. And then -2, 1/4. And connecting these, we get this exponential growth graph. This is the graph of y equals 2 to the x. What about with 1/2 to the x power? Well, with this one, when x is 2, the y value is down at 1/4. When x is 1, y is 1/2. When x is 0, y is 1. So, okay, it crosses at that same point on the y-axis. When x is -1, y is 2. And when x is -2, the y value is 4. Okay, if we connect these points, well, the graph is kind of going down like this. It's like the mirror image of that first graph. Okay, so this is y equals 1/2 to the x power. So one thing that we might notice about these two graphs is, well, they look like they're reflections of each other. They look like they're reflections across the y-axis. They're mirror images of each other across the y-axis. And we've seen that before. Like typically to get a reflection across a y-axis, I take my function, whatever my function f of x was, and I change the x that I'm plugging in, changing that to a negative x. But that's a little weird because with these two functions, I don't see a negative x in them right now. But it turns out it is there. It's just a little hidden. In fact, if I do a little bit of simplification on this function, we'll see it appear. Okay, because 1/2, I can rewrite it as a 2 to the -1 power. So I got that whole thing to the x. And then if I have a power to a power like this, that means multiply the power, so we'll get 2 to the -x. And there's my negative x. So this makes it a little bit more apparent that these graphs are actually reflections of each other. Basically, 1/2 to the x power, that's the same thing as writing 2 to the -x. All right, so we got these two graphs. All right, let's take a look at some more examples. All right, so part B. Now I want to graph y equals 2 to the x and y equals -2 to the x. Okay, so y equals 2 to the x, well, that one we've graphed a couple times now. That one's the one that goes up like this. It's got this horizontal asymptote at the x-axis. Then it's got this balance point at 0, 1, and then it keeps rising. Y equals 2 to the x. And if we put a negative sign in front of the whole function, well, that's going to be a reflection, but this time across the x-axis. So we will get, we'll put it in a different color, we will get a reflection across the x-axis. That is going downward like this. Now that balance point has gotten reflected to 0, -1. This is y equals negative and then 2 to the x. All right, let me just write in words that these graphs are reflections. These are reflections across the x-axis, reflections across the x-axis. Okay, and then finally in part C, we got y equals 2 to the x one more time. Let me draw that in. All right, so hopefully we're getting more and more comfortable with drawing that graph of y equals 2 to the x. Okay, so y equals 2 to the x, and it's got this balance point at 0, 1. And then if you change the x to a negative x and you put a negative in front of the whole thing, well, that's going to reflect the whole graph across both axes, across the x-axis and across the y-axis. Okay, so this previous graph was a reflection across the x-axis. I now got to take that and reflect that across the y-axis. So reflecting that graph across the y-axis, we would now get, well, it's going to go to this balance point, but it's going to go this way up to the x-axis and then drop down quickly this way. Okay, so with this extra reflection, well, the balance point stays there at 0, -1. And we've seen before that when a graph gets reflected across both axes, that's a reflection across the origin. If it reflects across both the x and the y-axis, that's a reflection across the origin. And I could see that because, well, if I take any point on this graph, on the original graph, and I draw the mirror image of it across the origin, So if I draw a line to the origin and then go equally far across the origin, well, I get a point on the new graph. So that's happening for any point I take on the original function. The mirror image of it across the origin is on the new graph. Okay, all right. Let me just label the equation of this blue one. So this was y equals negative and then 2 to the negative x. Okay, let's take a look at another example. Let's flip the page for this. Now, what if I change the base and I do y equals 3 to the x? Okay, so for this, I'm going to make another table of values. So I'll keep track of x. But this time, I'm going to do two extra columns. I'll do a column for 2 to the x as well as for 3 to the x. And I'll plug in -1, 0, and 1. Because I'm going to want to compare which one's got the bigger y values. Okay, if I plug -1 in, first I get 1/2. With 3 to the x, I get 1/3. If I plug 0 in to both of these, I'll get 1. And plugging 1 in, I'll get 2 here, and 3 to the 1 is 3. Okay, so let's take this info, let's plot these points. So I'm going to label -1 on the x-axis and +1. Okay, and then on the y-axis, I'll also label some tick marks, but it's not going to be to scale. Let's say this is 1, this is 2, this is 3. Okay, so let me draw the graph of y equals 2 to the x first. Okay, so when x is 0, y is 1. When x is 1, y is 2. When x is -1, the y value is 1/2. So if we connect these, we are getting a graph that is looking like this. That is our graph of y equals 2 to the x power. With y equals 3 to the x, well, it goes through that same point on the y-axis. Still goes through 0, 1. Okay, but when x is 1, the y value is larger. So it is going up higher this way, going up higher that way. But on the flip side, if I plug in -1 in for x, the y value is down at 1/3, which is lower than 1/2. So on the other side of this balance point, it goes below the graph of y equals 2 to the x. Okay, so that y equals 3 to the x, as soon as I pass that balance point, it's getting a whole lot steeper than even the graph of y equals 2 to the x. Okay, so in general, the bigger I make the base, like if I did 5 to the x or 7 to the x, it's going to even increase that steepness more. Okay, all right, let's look at another example. Now, what if I did these previous two graphs, but I changed those x's to negative x's? Okay, so we've seen what that's going to do. That's going to be a reflection. That's going to reflect these graphs across. So changing the x to a negative x reflects it across the y-axis. So let's reflect both of these across the y-axis. So first, I'll reflect that y equals 2 to the x graph. I won't bother with tick marks right now. I'll just draw the general shape. So that's my y equals 2 to the x. I'm just going to label this balance point at 0, 1. And then with 3 to the x, when I reflect that, well, going to the left, it's going to go higher up than the graph of y equals 2 to the x. And then going to the right of the balance point, it's going to go below. It's going to go below that graph. So this orange one, this is the graph of y equals 3 to the negative x. And whoops, I just realized for the other one I wrote 2 to the x, but it should have been 2 to the negative x. Okay, all right, so these are a number of quick examples that we did about graphing exponential functions and reflections of them, and also changing the base and seeing how does that affect the shape of the graph. It affects the steepness. All right, so I'm going to end this video with a tougher graphing example. Here's one I'm going to need to do with shifting and reflecting and finding my parent function. I want to sketch the graph of y equals negative 2 to the 5 minus x power plus 64. Label any relevant points, things like intercepts or balance points, and state the domain of the range. Okay, so all right, so let me think about my parent function. So I'll write y equals, and I'll think about what that is. Let me go ahead and draw in some axes just to get ready. Just to get ready for some of the subsequent steps, I'll draw in some more axes here. So that's going to be my second step. And my third step, I'll get a set of axes ready there. Okay, so when I look at this function, I have this exponential function because that variable is an exponent. So, well, now we know what exponential functions look like. So we have new parent functions to work with. In fact, the parent function for this graph is going to be 2 to the x. Okay, so I'm going to call that more generally, I'm just going to call that f of x. Okay, and we know the graph of y equals 2 to the x. We've drawn that a number of times in this section. Okay, y equals 2 to the x. It's looking like this, our exponential growth graph. And the balance point on that graph is at 0, 1. 0, 1. Okay, so remember, when we graph something by shifting and reflecting, generally we want to work inside out. And there's another kind of subtle point about graphing these things by shifting and reflecting that I want to recall. And that's if inside the function, so where the x is getting plugged in, so for this function, the x is getting plugged in to the exponent. If right next to the x, inside the function, if there's a negative sign right next to the x, but there's also a number, which is this 5, right next to the x, then we do this step first, which is we are going to factor a negative out of those two terms. So if I factor a negative out of those two terms, which happens to be the exponent, well, that'll change that negative x to an x, and it'll change the 5 to a minus 5. And then at the end, I still get that plus 64. Right, that was something that we saw back in our shifting and reflecting section. That if we see right next to the x a negative sign and a number right next to the x, first factor that negative sign out of those two terms. And now I'm going to first deal with that negative that is there, that gets put in next to that x. Okay, so I'm going to draw the graph of y equals 2 to the, and I'm going to replace the x with a negative x. All right, so in terms of my general formula, we are taking our f of x, our previous f of x, and we are replacing the x inside the function with a negative x. Okay, that's going to be a reflection. Replacing x with negative x reflects across the y-axis. Reflects this thing across the y-axis. Okay, so if I reflect it across the y-axis, well, the balance point, well, that's already on the y-axis, so that'll stay there. That's still at 0, 1. But then now my graph is going to rise this way, and it's going to fall and snuggle up next to the x-axis going that way. Okay, that's my reflection step. Now is where I'm going to deal with this minus 5. Okay, so to deal with that, I am going to take my previous formula, that y equals 2 to the negative x, and the x is going to get replaced. It is going to get replaced with a thing that I see inside of this parentheses. I'm going to replace it with x minus 5. So we are taking our general formula from before, which was our f of negative x, but now I'm replacing that x. I'm replacing that x with an x minus 5. Okay. So when we did this step first, where we factored the negative out, it helps us see what we are actually going to replace the x with. I'm actually going to replace with x minus 5. Whereas if we hadn't done that, and I just looked at this, we might think, wait, aren't we going to replace it with like x plus 5? Because that looks like a plus 5 there. And it turns out that would give us an incorrect shift. Okay. So when I do replace the x with an x minus 5 inside the function, that shifts the whole thing right by 5. Shifts it right by 5. So that includes the balance point. The balance point is going to get shifted. All right, so now it's going to be 5 units to the right. It's going to be at 5, 1. Okay, so yeah, balance points are not always on the y-axis. They can get shifted away from it. Okay, so it's important to draw them initially in the first step so that I can see as I shift and reflect where they end up from step to step. Okay, so then still over here, snuggling up next to the x-axis, and over here it's rising very, very, very quickly. All right. So now we are a couple steps away. There's two other things. There are two other things to put in. I'm not sure why that's there, actually. Let me go ahead and erase. Oh, weird. Okay. All right, let me go ahead and draw in some more axes just to get ready for these remaining steps. So another set of axes. And then one more set of axes. All right, so we got two more steps to go. So there's a couple things left. There is this other negative sign in front of this portion, and there's this plus 64 at the end. So what I have to deal with next is that negative sign in front of the function, because that is multiplying it, and that takes priority over adding a 64 at the end. So I'm going to get y equals, we got that 2 to the negative parentheses x minus 5, and in front of all of that, we are putting a negative sign. In terms of my general formula, we have taken our f of parentheses negative. Within there, parentheses x minus 5, that's what we had up until now. And we're putting a negative in front of that whole general formula. Okay, that's going to be a reflection. That reflects it. If I put a negative in front of the whole formula, it reflects it across the x-axis. Reflects it across the x-axis. So my balance point, it's going to get reflected to the other side of the x-axis. Now it's going to be down here. The x-coordinate stays the same as 5, but the y value becomes -1 when it gets flipped down. Okay, and then I'm going to draw that graph once it got flipped down. Okay, so it's going to snuggle up next to the x-axis going this way, and then this way, it'll drop down rapidly. All right, one last step to go, which is I got to add that 64 at the end. Got to add that 64 at the end. So I'm going to take my equation is y equals, what do we got currently? -2 to the negative parentheses x minus 5. And now at the end of that, I am going to be adding this 64. Adding a 64 at the end. So that is a shift. That shifts it, and that's going to be shifting it up by 64. Okay. So what I'm going to begin by drawing is actually, there was a horizontal asymptote in every graph up until this point. And that horizontal asymptote was going through the x-axis. Okay, so that's at 0. Okay, if I shift that up 64 units, well, now that horizontal asymptote is going through 64 on the y-axis. It's a horizontal asymptote going through 64 on the y-axis. And let's shift up the balance point. That balance point, if I shift it up 64 units, is going to be at 5, 63. Okay, then I'm going to draw the shape. Okay, so this way it's snuggling up next to the x-axis. The other way, before I draw the other way, I might have a question about, well, will it have a positive y-intercept like that? Or will the y-intercept be negative like this? Maybe let's find the intercepts first before I draw that remaining portion. Okay, so if I try to get the y-intercept, we plug 0 in for the x. So that'll give us y equals -2. And if I plug in 0 for the x in the exponent, I'll get 5 as the exponent, plus 64. Okay, so this is -32 plus 64. That is 32. Okay, so my y-intercept is at x is 0, y is 32. So that is a positive y-intercept. So my graph, I expect to be, having this positive y-intercept and then going down like this. So let's find the x-intercept and let's see if that's checking out based on this graph. My x-intercept. Now I let y be 0. So I'll get 0 equals -2 to the. And you know what, just for simplicity, let me go ahead and use this original form now. Because that's the same as what I have, but it just looks a little simpler when I'm solving my equation. -2 to the 5 minus x, and then plus 64. Okay. All right, so now to solve this equation, I can move this negative power term to the left. All right, that'll give me plus 2 to the 5 minus x equals 64. So I have 2 to a power equals 64. But 64 is 2 to a power. It's 2 to the I'll put it in a different color. It's 2 to the 6th. 2 to the 6th. So if I have 2 to a power equals 2 to a power, well, those powers got to be the same. That means 5 minus x has to be equal to 6. Okay, and if I isolate the x here, we get x equals -1. So my x-intercept is at -1, comma 0. -1, comma 0. Let me go ahead and label those points. So x-intercept is at -1, comma 0. Y-intercept was at 0, comma 32. So those are my intercepts. So what else did this want? It wanted me to label all the relevant points. Maybe I should say explicitly that this point right here, this is the balance point. I want to have that labeled. Okay, we already labeled the y-intercept and the x-intercept. All right, what else did the problem want? Asymptotes, those are relevant things. There's a horizontal asymptote. Horizontal asymptote. So horizontal asymptote is going through something equals 64. Something equals 64. And every single point on this horizontal asymptote has got the same y value. Y equals 64. Okay. So one of those relevant points, and then it said find the domain and the range. So domain, I'll put D for domain, R for range. My x values could be anything. Domain is -infinity to positive infinity. The range, the y values start all the way down here at going to -infinity. And the y values get really, really close to 64 going this way, but they never reach 64. So comma 64 and parentheses. All right, and that is everything I wanted. Graph, relevant points, asymptotes, domain and range.